Okay, so for checking the stability or the utilize of Jacobi iteration, we can check two things. The condition for Jacobi to work. Okay, the condition for Jacobi to work. We can have two conditions. One is called wave condition. So wave condition, which is called straight diagonal dominance. It's called SDD. Okay, so this is a wave condition. What is wave condition means? If your system is followed by this straight diagonal dominance, it may work. For the Jacobi iterations, it may not. But if your Jacobi iteration will work, then it must fit for this straight diagonal dominance. Okay. There is another strong condition, and that is the eigenvalue of the matrices. So if your matrices of the Jacobi iteration is the eigenvalue is smaller than 1, the absolute number of the eigenvalue is smaller than 1, then it must work for Jacobi iteration. But if that is over 1 for the absolute number, then it won't work. Let's see why these two conditions will work for Jacobi iterations. Let's see why. Okay. So let's see first the SDD, which is the straight diagonal dominance. Okay. What is SDD? The straight diagonal dominance. What is SDD? So it means the AKK has to be over the rest of the elements at that row. J is now equals to Kn. So that is the sum of AKJ, means the rest of that row. So if you have the system, for example, A is equals to 4, 4 minus 2 minus 1 minus 8, 1, 1, 1, 5. And for this system, A is your before the swap. The AKK, okay, the AKK, which is A11 here, A11, is bigger than the sum of these two, right? It's bigger than the sum of these two. So the first row is satisfied for the SDD. For the second row, the sum of the absolute number of AKK, right, is equals to 8. The sum of the rest area will be smaller than this A22. So this one is satisfied as well. For this one, the A33 equals to 5. The sum of like A31, A32 is equals to 3, smaller than this 5. So it's still satisfied for the SDD. So it's satisfied SDD and converge. So this is converge. How about after we swap? We swap, which is the last row going to the top, right? So minus 2, 1, 5. This is 4 minus 8, 1. This is 4 minus 1 minus 4 minus 1, 1. So this is, we swap the system. We swap the system. A11 is smaller. The absolute number of A11 is smaller than the sum of these two. This row is still satisfied, but the first row is already not satisfied. This row is now satisfied as well because the A33 is smaller than the sum of these two. So this is non-SDD and not converge. Okay, so basically it didn't meet for the straight diagonal dominance. It must not be the Jacobi iteration. If that satisfied, we still need to check whether the eigenvalue of the matrices is satisfied or not. If not satisfied, still it couldn't let Jacobi to work. So you have to tell what is the weak condition, what is the strong condition. Okay.